comes to your mind when we talk about numbers?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Obviously, it is something to count with. I can count like this: 2, 4, 6, 8, 10. This is counting by twos. I can count by twos. Even I can count like this if I start with 5 and I count by threes. That is 5. Then adding 3 to it, I get jump to 8 and 11, 14, 17. I started counting with 5 and I counted by threes. कभी कभी ऐसी जरूरत होती है कि कुछ चीजें 3-3 में होती है, 3-3 के ग्रुप में, तो उन्हें 3 एक साथ, जैसे कुछ ट्राइंगल्स हैं, आपको पहले से 5 लाइंस दे रखी है और अब आपको बहुत सारे ट्राइंगल्स दिए हुए हैं और आपको पता लगाना कुल कितनी लाइंस सेगमेंट्स हैं. तो आप क्या करेंगे, 5 से स्टार्ट करेंगे. अब 6, 7, 8 बार बार करने के बजाय क्या करेंगे, ऑब्वियसली एक ट्राइंगल में 3 साइड्स होती हैं, तो नाउ स्टार्टिंग विद 5 विल काउंट बाय थ्रीज. 5, नेक्स्ट ट्राइंगल देखते हैं, 5 and 3 8, नेक्स्ट ट्राइंगल देखा 8 and 3 11, likewise this. So counting can be done in many different ways. You can count in halves. आपके पास आधा आधा किलो के पैकेट्स हैं 500 ग्राम्स के, तो आप कैसे काउंट कर सकते हैं, half, 1, 1.5, 2, 2.5, 3, 3.5. Likewise, we can count. So, what are the natural numbers? The numbers which can be used for ordering the objects, the ordinary counting numbers. अगर आपको कुछ चीजें दी और उसको एक ऑर्डर में अरेंज करना है, सपोज आप उसे असेंडिंग ऑर्डर में अरेंज करना चाहते हैं, तो फर्स्ट, सेकेंड, थर्ड, फोर्थ, फिफ्थ, मान लिया आपके पास 100 है तो अप टू 100. या आप इसे डिसेंडिंग में अरेंज करें, 100, 99, 98, रिवर्स काउंटिंग जिसे बोलते थे, अप टू 1. सो दिस जो नंबर्स हम ऑर्डरिंग करने में काम में लेते हैं, द ऑर्डिनरी काउंटिंग नंबर्स आर कॉल्ड नेचुरल नंबर्स. सो द वेरी फर्स्ट थिंग इज नेचुरल नंबर्स. द ऑर्डिनरी काउंटिंग नंबर्स आर कॉल्ड नेचुरल नंबर्स. अब अगर इन्हें सेट की फॉर्म में लिखे, सेट्स को कर्ली ब्रैकेट्स में लिखे जाते हैं, सेट के एलिमेंट्स, और दो एलिमेंट्स के बीच में कॉमा लगाई जाती है. दिस सिंबल इलिप्सिस, 3 डॉट, अगर आप कुछ लिख रहे हैं और बीच में कुछ जगह जानबूझकर छोड़ रहे हैं या वो अंडरस्टूड हो, तो हम एग्जैक्टली 3 डॉट्स लगाते हैं. आप किसी भी बुक में देखिएगा, ऐसा नहीं है कि 1, 2, 3, 4 बहुत सारे डॉट 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 लगा दिए. इट्स नॉट लाइक दैट. वी पुट इलिप्सिस, स्टैंडर्ड नोटेशन है, 3 डॉट्स लगाए जाते हैं. इसको रिवर्स ऑर्डर में भी लिखा जा सकता था, नेचुरल नंबर्स ऐसे 1, 2, 3 डॉट्स, नाउ 6, 5, 4, 3, 2, 1. बट कन्वेंशनली, परंपरागत रूप से हमें असेंडिंग ऑर्डर में अच्छा लगता है. हम 1, 2, 3, 4, 5, 6 एंड सो ऑन. सो अगर आपसे कोई पूछे व्हाट आर नेचुरल नंबर्स, देन योर आंसर मस्ट बी द ऑर्डिनरी काउंटिंग नंबर्स आर कॉल्ड नेचुरल नंबर्स. ऐसा ना बोले जो 1 से स्टार्ट होते हैं. आई कैन स्टार्ट विथ 1 and I can count by threes. So 1, 4, 7, ये तो सारे नेचुरल नंबर नहीं आए. तो हमें अगर सारे नेचुरल नंबर्स चाहिए, मींस नेचुरल नंबर्स को डिफाइन करना है, तो सिंपली विल से द ऑर्डिनरी काउंटिंग नंबर्स. अगर आप किसी बिल्कुल छोटे से बच्चे, अबोध बच्चे को, किसी बिल्कुल कोई भी जिसको बहुत ज्यादा मैथमेटिक्स नहीं आती, उससे भी आप काउंटिंग का कहेंगे, तो he or she will start with 1. It is very obvious and it will count by ones. Right. Now, वर्षों तक, हजारों वर्ष तक ये नंबर सिस्टम हमारे लिए पर्याप्त रहा. लेकिन एक बार ऐसी प्रॉब्लम आई. मैं इस व्हाइट बोर्ड के 2 पार्ट कर रहा हूं. लेफ्ट पार्ट में मैंने कुछ सिंबल्स बनाए और राइट पार्ट में भी बनाए. एक भी नहीं है. वेल, लेफ्ट पार्ट में अगर आपसे पूछे हाउ मेनी सिंबल्स आर देयर, 1, 2, 3. Okay, we are getting the answer in natural numbers. But अगर right part में देखें, इस side में, how many symbols can you see? The answer is not there with this set. There is no element here, there is no symbol here. The nullity, शून्यता जिसे बोलते थे, वो यहां पर नहीं है. तो शून्य को इंट्रोड्यूस किया गया. शून्य के लिए जो सिंबल दिया वो आर्यभट्ट ने दिया. और ऐसा नहीं है कि शून्य को जैसे ही इन्वेंट किया गया. इट वॉज अ मेजर ब्रेक थ्रू इन ह्यूमन सिविलाइजेशन. ऐसा नहीं कि शून्य जैसे ही आया दशमलव पद्धति बन गई, डेसिमल सिस्टम बन गया और हम बहुत जल्दी जल्दी ऐसा करने लगे. इसमें हजारों वर्ष लगे इसको डेवलप होने में. आज हम इस नंबर सिस्टम को देख रहे हैं और बड़े आराम से एक्सेप्टेबल है, ये हमें बहुत जल्दी से समझ में आ जाता है. लेकिन इसके पीछे बहुत लंबी कहानी है. वेल, अभी हम हिस्ट्री में नहीं जाएंगे. तो बात करें, क्योंकि यहां पर शून्यता, नलिटी या जीरो नहीं था, तो अगर हम इस नेचुरल नंबर के सेट में all counting numbers along with zero, if we include zero in this set of natural number, we get the set of whole number, which is denoted by W for whole, that is whole number. So we have the counting numbers, the ordinary counting numbers 1 2 3 4 5 6 7 8 and so on. And we have, if we include zero in this set, then what we get is we get the set of whole numbers. Okay, it was okay. अब मानव सभ्यता को लगा, ह्यूमन सिविलाइजेशन को लगा कि अब हम नंबरों के मामले में, संख्याओं के मामले में हम पूर्णता प्राप्त कर गए, होल नंबर. अब हमें और किन्हीं पूर्ण संख्याएं, अब हमें और किन्हीं नंबर्स की जरूरत नहीं पड़ेगी. लेकिन अब आई बात उधार वाली. अगर आप बहुत सिंपल कॉन्सेप्ट में देखें कि अगर आपने किसी से 5 रुपीज लिए तो आपके पास आए, इफ यू हैव टेकन 5 रुपीज देन यू हैव +5. इफ यू हैव गिवन समवन, if you have 100 rupees and you are given, then you will have 100 minus 5, that is 95. So if you have nothing and you have given 5, then this answer was not here. आपने एक छोटे नंबर में से एक बड़े नंबर को सब्ट्रैक्ट करें, एक बड़े नंबर में से छोटा नंबर सब्ट्रैक्ट करें. इट्स ऑल राइट. 7 minus 4, 7 minus 4 is 3. Okay, but what about 4 minus 7? अगर 4 में से 7 सब्ट्रैक्ट करें तो न्यूमेरिकली इनका डिफरेंस 3 है, लेकिन -3. 4 मेरे पास आए और 7 मैंने दिए. अभी लिए दिए, अब लिए किसने लिए, किससे लिए, सो इससे क्लियर नहीं हो रहा. तो मैथमेटिक्स में इसे सिंबलाइज किया गया पॉजिटिव, नेगेटिव. अगर आपके पास आए दैट इज प्लस, अगर आपने दिए हैं दैट इज माइनस. लिए दिए, दोनों केसेस में लिया भी और दिया भी. सामने वाले ने दिया, आपने लिया. सो पॉजिटिव गेन, पॉजिटिव लॉस, नेगेटिव, जिनके बारे में हम और बात करेंगे, कुछ क्वेश्चंस जब लेंगे. तो इनको जब इंक्लूड किया, यहां पर डेफिनेशन थोड़ा सा, कई लोग जल्दबाजी में बोलते हैं कि द होल नंबर्स अलोंग विद द नेगेटिव नेचुरल नंबर्स. नो नेगेटिव नेचुरल नंबर. ध्यान दीजिएगा, कोई भी नेचुरल नंबर नेगेटिव नहीं है. तो हाउ कैन यू टॉक अबाउट नेगेटिव नेचुरल नंबर्स? एक्चुअली इट इज होल नंबर्स अलोंग विद नेगेटिव्स ऑफ नेचुरल नंबर. हम इनके एडिटिव, इनवर्स या जिसे बोलते हैं नेगेटिव्स ऑफ. अगर ये ऑफ वर्ड आप नहीं बोलते हैं, ध्यान से देखिएगा, यू कैन नॉट से नेगेटिव नेचुरल नंबर. देयर इज नो, if I ask you, go and bring negative natural numbers, is there any number in the natural numbers which is negative? No, not at all. You do not have any negative natural number. So what you say is all natural numbers 0, yeah, you can replace all natural number and 0 with whole numbers, all the whole numbers and negatives of natural numbers, negatives of natural number. Do not forget to speak of negative of. प्राकृतिक संख्याओं का ऋणात्मक रूप, ऋणात्मक प्राकृतिक संख्याएं नहीं. There are no negative natural numbers. Negative natural numbers does not exist. नेचुरल नंबर्स नेगेटिव होते ही नहीं है, इनका नेगेटिव फॉर्म हो सकती है, इनकी नेगेटिव्स हो सकते हैं, इनके एडिटिव इनवर्स हो सकते हैं, बट अ नेचुरल नंबर कैन नेवर बी नेगेटिव. सो ऑल नेचुरल नंबर्स, zero and negative of natural numbers form the set of integer I or z. I for integer, z is taken from the word jehlan, a Latin word which means count. So this is integers. So now we have positive counting numbers, we have the negatives of these counting numbers and zero. This is the set of integers. Now let's talk about prime numbers. What are prime numbers? To be precise, we'll speak the definition like a number greater than 1 means 1 is excluded. Again, here in the definition we have taken number greater than 1. That leads us to a conclusion that 1 is neither prime nor composite, because it says a number greater than 1 means 1 is not included here. Here again we are taking like numbers greater than 1, that means 1 is neither included here nor included here. So 1 is neither prime nor composite. 1 is neither a prime number nor a composite number. Now a number greater than 1 is called a prime number if a number greater than 1 is called a prime number if it has exactly neither less than nor more than, if it has exactly two factors, namely 1 and the number itself. So we have the numbers 1 2 3 4, the number greater than 1, this is 1 will not be taken, greater than 1. Now if I take 2, yes, 2 has two factors, 1 and 2, exactly two factors, 1 and the number itself, so it is prime. What about 3? 3 has exactly two factors, 3 is divisible by 1, 3 is divisible by 3. Okay, 4 actually has, it is divisible by 1 as well as 2 as well as 4. So it has more than two factors. The numbers having more than two factors are known as composite numbers. So 4 is a composite number, 5 again is a prime, 6 is a composite. Every second number will obviously be a composite because it will be divisible by 2. Out of any two consecutive number, one must be divisible by 2. Means if you choose any two consecutive numbers, one of them must be a composite number. More than one may be composite. Suppose you take 9 and 10, both are composite. But at least out of any two consecutive numbers, at least one will be composite, because out of these two, one is must a multiple of 2, that is an even number. So 2 is the only even prime number, because if you take any even number other than 2, suppose you take 4, 6, 8, then it will also be divisible by 2. That means it will have 1 as a factor, the number itself as a factor, and 2 will also be its factor for any even number other than 2. 4, 6, 8. That means it will have 1 itself and 2. That is more than 2 factors. So it will be a composite number. So 2 is the only even prime number. There is only one even prime number, that is 2. Other than 2, if a number is even, then it cannot be prime, because it will have more than 2 factors, that is 1 itself and also 2. Okay. There is a fact that there are 25 prime numbers up to 100. If you list them out, you can find there is a method, we will talk about it later. There are 25 prime numbers up to 100. In probabilities, sometimes the question is asked, if one number is taken out from first 100 numbers, what is the probability of getting a prime number? So we have to add a total, we have 100 numbers. How many primes we have? 25. So the probability is 1 by 4. Okay. Composite numbers, number greater than 1 which are not prime, can be taken as composite, or simply the numbers having more than 2 factors are known as composite number. 1 is neither prime nor composite. 2 is the only even number which is prime, because if you choose any even number other than 2, 4, 6 or any number, then any other number than 2, any other even number 2, suppose I take 4, so it will be having a factor 2. 1 is always a factor of every number. Now the number itself is always a factor of itself, so 1 and 4 will be there, and it is also divisible by 2. If you take 6, then 6 will also have more than 2 factors. So all the other numbers which are even will be composite, but 2 is the only prime number. And one more fact, 2 is the smallest prime number. If someone asks you which one is the smallest composite number, your answer must be 4. And the greatest does not exist because the counting goes forever. Now we talk about rational and irrational numbers. Now, before talking about rational and irrational numbers, let's first talk about number line. Well, we'll take the help of geometry here. Euclidean geometry says that a point is that which has no part, or in simple words, a point has no length, no breadth, no height. Even if I'm making this, actually it is not a point because it has a certain length, certain breadth. If you zoom it out, you can find a million, infinite many points in this dot. So it is a hypothetical concept, point, which has no length, no breadth, no height. Practically it is not possible to trace it, but it is hypothetical. When we make a dot, we consider it as a point. Well, when we take a lot of points in a line, then this is known as a line. A line is a breadthless length. A line is a breadthless length, means it has no breadth. It has two directions, which we say left, right, or we'll take positive and negative, but it has one dimension. The line has only, the point has no dimension. It is no length, no breadth, no height. It has one dimension, that is length. Let's talk about it. See, this is a three-dimensional structure. Here it has length, it has breadth, it has height. If I take one of this layer, then it is a two-dimensional structure. It has length and breadth. We have considered the height as 0. Hypothetically, we have taken, it is not possible to have height 0, but hypothetically we are considering the height as 0. So it has length and breadth. If I talk about this edge only, then it is a line which has only one dimension, that is length. So this is what we call a line which is extended both the side indefinitely. And now on this line, if I try to mark the numbers, then this line will be said to be a number line. Well, now for a number line, we must have a point of reference. क्योंकि जब तक point of reference नहीं, if you don't have point of reference, कहाँ से distances नाप रहे हैं, then it is useless to say. आपने वो जोक सुना होगा कि एक टीचर क्लास में एक बच्चे को बोलते हैं, सोहन तुम्हारी बहुत शिकायत है, बताओ तुम्हारा घर कहाँ है, मुझे तुम्हारी शिकायत करने तुम्हारे घर आना पड़ेगा. सोहन बोला, सर मेरा घर मोहन के घर के सामने है. ओके, तो बताओ मोहन का घर कहाँ है? कि मोहन का घर मेरे घर के सामने है. अच्छा ये बताओ दोनों का घर कहाँ है? कि सर दोनों का घर आमने सामने है. तो आप समझ सकते हैं, जब तक पॉइंट ऑफ वो मुझे ये बताओ कि आपका घर स्कूल से किस तरफ और कितनी दूर है. दैट मीन्स द स्कूल, वी मस्ट हैव अ पॉइंट ऑफ रेफरेंस जहां से सारी डिस्टेंसेस मेजर की जाती है. एंड दैट पॉइंट ऑफ रेफरेंस इज टेकन एज द ओरिजिन, O0, that is considered to be at 0 distance. Now in conventional method, if you walk towards right to 0, then you are going to the positive direction. And if you are going to left, then this is negative direction. Mind it, 0 is neither positive nor negative. 0 is 0. Like in atoms, electron is negative, proton is positive, but neutron is neutral, that is neither positive nor negative. In the same way, on the number line, 0 is a number which is neither positive nor negative. 0 is neither positive number nor negative number. Yes, 0 can be multiplied by a negative number, that will also give us 0. That is, additive inverse of 0 is 0 itself, but 0 is neither positive nor negative. You can negate 0, that will give you 0. It must be clear that 0 is neither positive nor negative. That's why if I say, if I leave all the positive numbers, if I say leave all the positive numbers, that means, that doesn't mean that we have all negative numbers. We have three partitions: 0, positive real, negative real numbers, and positive real number. If I remove positive real numbers from the set of real numbers, then I don't not only get negative real numbers, but also I get 0. So there are three partitions of number line with respect to sign. No sign, that is 0, neither positive nor negative. Positive on the right hand side of the number, on the right hand side of the origin, all the numbers are positive, and on the left hand side of the number, all the numbers are negative. Now, why we have discussed this definition? Actually, if you choose any two numbers, then between these two numbers there will be infinite many points. So we can conclude that there are infinite many, and each point represents a number. So there are infinite many numbers between any two numbers. Till now we have discussed integers. So between any two integers there are infinite many points, and each point represents a number. So between two integers there are infinite many numbers. Now what these numbers are called? Let's talk about the numbers in detail. Now we talk about rational numbers. A number which can be expressed in the form of P upon Q. It's just symbol. You can write here X, a number which can be written in the form of X upon Y, where X and Y are integers, and the denominator should not be 0, because division by 0 is not defined. If you divide a number, any non-zero number, by 0, suppose you have 5 chocolates, or if I say if you have 1 chocolate and you divide it in 0 parts, means how many parts can you make? Obviously you have 1 chocolate and you are to distribute into it in, you are to divide it by 0. Now how many parts will be there? This is known as infinite, symbolized as infinite. आपने पहले को 0 दे दिया, दूसरे को भी 0 दे दिया, तीसरा है उसको भी 0, चौथा है 0 0 0 देते रहे, तो आप कितने ऐसे पार्ट कर सकते हो? ऑब्वियसली आप किसी को कुछ दे ही नहीं रहे हो, इसका मतलब ये हमेशा आपके पास बना रहेगा, आप देते ही जाएंगे देते ही जाएंगे देते ही जाएंगे और ये कभी खत्म नहीं होगा। इसका मतलब ये इनफाइनाइट होगा, यानी डिवीजन बाय 0 इज नॉट डिफाइंड एंड इनफाइनाइट इज नॉट अ रियल नंबर। हम बात करते हैं जब हम नंबर लाइन बनाते हैं, नंबर लाइन के राइट एंड पर हम यहां पर लिखते हैं प्लस इनफाइनाइट। कृपा करके यहां ना लिखें प्लस इनफाइनाइट, बिकॉज इसका मतलब तो इनफाइनाइट इस नंबर लाइन पे है। नो, इनफाइनाइट इज नॉट अ रियल नंबर, सो इट डज नॉट लाई ऑन दिस नंबर लाइन। सिमिलर केसेस विद माइनस इनफाइनाइट। तो हम जब नंबर लाइन बनाएं राइट हैंड साइड पे यहाँ पे इनफाइनाइट, इट विल टेंड टुवर्ड्स इनफाइनाइट एंड इट विल गो टुवर्ड्स माइनस इनफाइनाइट। द रियल नंबर्स आर between minus infinite to plus infinite. इनफाइनाइट, माइनस इनफाइनाइट से प्लस इनफाइनाइट के बीच में जितने भी नंबर हैं वो सारे रियल नंबर्स हैं। माइनस इनफाइनाइट इज नॉट अ रियल नंबर, मोर ओवर इनफाइनाइट इज नॉट अ रियल नंबर, इसीलिए इसको नंबर लाइन से बाहर की तरफ हम लिखते हैं, इधर प्लस इनफाइनाइट इधर माइनस इनफाइनाइट। अब कोई भी ऐसा नंबर जिसको दो इंटीजर के रेशो की फॉर्म में लिखे जा सके, दो इंटीजर्स का कोशेंट लिखा जा सके, कोशेंट ऑफ इंटीजर्स, that is known as a rational number, because R stands for real number, that's why we have taken the word Q to represent quotient. So quotient Q represents the rational number, जैसे 2/3 -5/7 1 2 3 4 5 6 7 -5 माइनस, कैसे It can be written as a quotient. 1 can be written as 1 upon 1. 7 can be written as 7 upon 1. 0 can also be written as 0 upon 1. So 0 is also a rational number. 0 is neither positive nor negative, but 0 is a rational number. Now you can think a number which is not rational. A number which is not rational is known as irrational. That means if a number is rational, then it cannot be irrational. If a number is irrational, then it cannot be rational. 0 is rational, so it is not irrational. But 0 is neither positive nor negative. That must be there on your mind. Well, minus 5 is rational because it can be expressed in the form of p upon q. This can be written as minus 5 upon 1. If you do not see any denominator, you can write the denominator as 1. Something upon 1 is the number itself. Root 4, actually on solving you will get 2, and 2 can be written as 2 by 1. So root 4 is a rational number. Again, cube root of 8, that is 8 raised to 1 by 3. 8 is 2 raised to 3. So this will give us 2. The cube root of 8 is 2. So cube root of 8 is also a rational number. 1.4, if you write it in quotient form, this will give us 14 by 10. Simplest form, 7 by 5. This is a rational number because it can be expressed as the ratio of two integers where the denominator is not 0. Well, irrational numbers, it can be defined in two ways. The real number which are not rational. The real numbers which are not rational are simply irrational. Or a real number which cannot be expressed in the form of p upon q, where both p and q are integers and q is non-zero, is known as irrational. Which cannot be expressed. Which can be expressed, it is rational. Which cannot be expressed, that is irrational number. So irrational number, q dash, is real set of real number minus set of rational numbers. Some examples: pi. Pi is an irrational number. It can never be expressed as the ratio of two integers. Though you are using pi is nearly equal to 22 by 7. We will discuss pi in another session. Pi is not exactly equal to 22 by 7. It is the approximate value of pi. So it is not the exact value. It is approximate value. It is approximate value of pi. Had pi been exactly equal to 22 by 7, then it must fit on the definition of rational number. So it must be rational. No, actually it is not rational because 22 by 7 or 3.14, which we use in the questions, is actually the approximate value of pi. We will discuss about pi in some other session. Similarly, e is irrational, root 2, root 3, root 5, cube root of 11, or simply square root of any non-perfect natural number is always an irrational number. If you take the square root of any non-perfect number, if you are taking the square root of a perfect number, then obviously it is rational. But you take any non-perfect square, right? Prime numbers are always non-perfect, so the square root of prime numbers is the best example. But if you take any non-perfect square, that is 6 is not a perfect square, so root of 6 will obviously be an irrational number. Now we talk about the 4 basic operations on the number line. If you go, here I am tracing the integers. If you take one distance unit, that is +1, then +2, then +3, +4, +5, -1, -2, -3, -4, -5, likewise. Well, the 4 basic operations on numbers are addition, subtraction. The first one is addition. If you need to add some two numbers, say 2 and 3, if you need to add this, then you go to 2 on the number line. First we reach to 2. Now we take 3 more steps to the right of it when we add. So 1, 2, 3, this will give us the result 5. So we can use this number line to add or subtract the number. Similarly, in case of subtraction, you go in the negative direction, in the backward direction. If I say what is the value of 2 minus 3, so what we'll do is we'll go and stand at 2. Okay, we have reached 2. Now take 3 steps in backward direction. So 1, 2, 3. This will take me to minus 1. So 2 minus 3 is minus 1. So we can perform addition and subtraction on number line. Similarly, in the case of multiplication, the third operation is multiplication. If we try to multiply, suppose I give 2 into 3, that is 2 times of 3, and it is commutative, or it may be written as 3 times of 2. 3 2s are 6 and 2 3s are 6. Both are same. So 2 times of 3 is how much? Let's try to evaluate it on the number line. This means 2 steps, and it is positive 2 steps forward. 2 steps forward of size 3. Actually counting by 3s. If you count by 3s 2 times, counting by 3. This is first 3, then this is second 3. Counting by 3s, 2 steps forward of size 3, or we can say 3 steps of size 2. Now 3 steps of size 2. 1, 2, the size is 2, again 2, and one more step, 3 steps of. We reach at 6. This is how we perform the product or the multiplication. Now, plus, addition, subtraction, multiplication, and now we talk about division, how the division or these numbers are represented on the number line. Suppose I have a number that is 3 by 5. So it can be written as 3 into 1 by 5. That is, now the unit, one unit is to be divided in 5 parts, and out of these 5 parts we are taken the third multiple of this, that is 3 parts. 3 times of 1 by 5. So to divide it 5, we make 4 parts. This 1, 2, 3, 4, 5. This will represent 1 by 5. This will obviously be 2 by 5. This is the 3 by 5, and this one is 4 by 5, and last one is 5 by 5, which is equal to 1. So 2 by 5 can be represented on this number line. So you can understand, on this real number you can represent any number. Any number on this point represents a number that may be rational or irrational. How irrationals are shown? Suppose I am to show root 2. What I do? I take 1 unit and a perpendicular 1 unit. Now if I try to complete this triangle, this gives me perpendicular square plus base square, that is 1 square plus 1 square, that is root 2. This length is root 2. If I mark it here, this is root 2. This is an irrational number. Well, after discussing number line, the real number line, we must discuss one more point, which is Euclid division lemma. इससे डिवीजन का प्रोसेस कैसे होता है वो भी डिटेल में डिस्कस हो जाएगा. वेल, यूक्लिड लेमा क्या कहती है? गिवन पॉजिटिव इंटीजर्स a and b, there exists unique q and r such that a is equal to b times of q plus r, where the remainder must be either 0 or less than the divisor b. Actually, this is the division process. A is divided by b and q is the quotient, and on dividing finally r is the remainder. So this dividend a can be written as b into q, divisor into quotient plus remainder. Here let's check it out. See, 2 2s are 4. On subtracting we get 1 because there is no digit left in the dividend. So this is the remainder. Because we are talking in integers, we will not perform the division to decimals. Okay, ये हो गया. इसमें यूक्लिड की डिवीजन लेमा ये देखते हैं. The dividend 5 is equal to this into this, that is 2 into 2 plus 1 bq plus remainder. So 5 is equal to 5. अब डिवीजन का प्रोसेस को समझते हैं. यहाँ जैसे यहाँ 12 एक ही डिजिट अगर लेता तो डिवाइड नहीं हो रहा, यहाँ जीरो भी लिखा जा सकता था, जीरो लिखकर फिर हम आगे बढ़ सकते हैं, लेकिन फर्स्ट टाइम में हमने दो डिजिट ले ली, अदरवाइज जीरो 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 भी लगा सकते। कंप्लीट प्रोसेस ऐसा है, एक डिजिट ली नॉट डिविजिबल, जीरो टाइम डिवाइड किया, तो रिमाइंडर इज 6। एक डिजिट कैरी डाउन लेने के बाद, ये हर एक डिजिट कैरी डाउन होने के बाद डिवीजन का प्रोसेस फॉलो होगा। सो 12 5s are 60, 12 5s are 60, so remainder is 0. Now 1 is carried down. अब ये 1 रिमाइंडर नहीं है, you can check it out. The dividend 601 is not equal to this into this plus 1. 12 into actually it is 5 plus 1. 12 5s are 60 plus 1, it is 61, but it is 601. So complete process क्या है? 601, 12 5s are 60, or you can make one more step. So 12 5s are 60. Now you are left with 0. कैरी डाउन, जैसे इसको कैरी डाउन किया, अब आपको डिवीजन परफॉर्म करना, हर एक डिजिट कैरी डाउन होने के बाद डिवीजन परफॉर्म होगा। ये डिवीजन परफॉर्म करने से पहले ये रिमाइंडर नहीं है, इट इज नॉट द रिमाइंडर। रिमाइंडर क्या होगा? 12 zeros are, zeros टाइम 0। अब सब्ट्रैक्ट करने पे दिस इज रिमाइंडर, वी हैव लेफ्ट विद नो डिजिट्स। अब देखो डिविडेंड में कोई भी डिजिट नहीं बची है, इसका मतलब अब सारी डिजिट्स आ चुकी है, हर एक डिजिट डिवाइड हो चुकी है, दिस इज रिमाइंडर, यू कैन वेरीफाई। 601 इज इक्वल टू दिस इंटू दिस, 12 इंटू 50 प्लस 1, 12 5s are 60, दिस इज 600 प्लस 1, 601। तो डिवीजन करते वक्त बहुत ध्यान दें, बहुत शांति से सारी चीजें देख के करें। जैसे इसमें मान लिया 11 से डिवाइड करना, 11 0 11, तो कुछ लोग डिवाइड करते 11 1s are 11, ओके, देन 0 है तो 0 लगा दिया, एंड फिर 11 1s are 11 कर दिया। तो इस तरह से ये 0 लगा दिया, फिर 11 ले लिया, और 11 1s are 11। दिस इज टोटली रॉन्ग, यू कैन चेक। 11,011 is not equal to this into this, that is 11 into 101 plus the remainder in case we are adding 0. So this is not equal to this, so it is wrong. So what is the actual process? Simple. करना क्या है? सबसे पहले 11 से डिवाइड किया, 11 1s are 11, पहले सब्ट्रैक्ट किया, एक बार में एक डिजिट को कैरी डाउन किया, कैरी डाउन होने के बाद हर बार डिवीजन प्रोसेस फॉलो होगा, मतलब ईच डिजिट विल बी डिवाइडेड। अब ये डिवाइड होगा 0 टाइम, सब्ट्रैक्ट किया, एक बार में एक डिजिट को कैरी डाउन किया, डिवीजन का प्रोसेस होगा क्योंकि 1 11 से छोटा है इसलिए 0 टाइम डिवाइड हुआ, 0 into 11 is 0, this will give me 1. Now this last digit is carried down, now perform the division, this is not remainder, still the division is to be performed, 11 1s are 11. Here our division is complete. Now this is equal to this into this plus this, that is 11,011 is equal to this into this, that is 11 into 1,001 plus 0, and it is correct. So you can understand, while division you must take care of each and every digit is divided. When it is carried down, the division process is to be followed, then only you will find the remainder. When the last digit has been carried down and it is divided, after that whatever you found is the remainder. You can try one more. For example, if you divide 100 by 3 and you want the answer in decimal, so I am writing 100.00. So 3 doesn't goes to 1, right? So this will give you simply 0 times. So now this will be carried down 10, or in the first go you would have divided 10 by 3. Now 3 3s are 9. 3 3s are 9. The remainder is 1. Now this one is carried down. This will give you 10. Now 3 3s are 9. On subtracting we get 1. Now you put the decimal and taking this digit. 3 3s are 9. Now remainder is 1. Again Take this down. Perform the division. 3 3s are 9. Again you are left with 1 and this process will continue. 3 3 3. It will never end because every time you are going to get the remainder as 1 and this will give you 33.33333333 and this kind of numbers 100 upon 3 whose decimal expansion is non-terminating but repeating. Non-terminating but repeating are also rational numbers because this can be expressed as P upon Q. So there are, when we talk about decimal numbers, if the division process terminates, suppose here if I want to need the answer in decimals, I will carry it down 10 decimal, 5 2s are 10, the remainder is 0, all the digits are ended and the remainder is 0, so 2.5. If the decimal expansion is terminating, terminate होना मतलब खत्म हो जाना, terminating, then it is rational. If it is non-terminating, then there are two cases, non-terminating and repeating. It is not terminated but the digit 333 or a set of digits is repeated, then this is also rational. But if non-terminating and non-repeating, non-terminating, non-repeating means terminate भी नहीं हो रहा और repeat भी नहीं हो रहा, इस तरह के decimal expansion होते हैं irrational, Q dash. So I hope we are clear with the real number system. When we talk about the decimal system, if the decimal expansion is terminating मतलब खत्म हो जाता है थोड़े decimal के बाद तो rational है, अगर खत्म नहीं होता लेकिन repeat हो जाता है यानी नॉन टर्मिनेटिंग बट रिपीटिंग तो भी वो रेशनल है. लेकिन अगर वो टर्मिनेट भी नहीं हो रहा, दोनों ही नो, नॉट रिपीटिंग नॉट टर्मिनेटिंग, रिपीट भी नहीं टर्मिनेट भी नहीं, नॉट रिपीटिंग नॉन टर्मिनेटिंग नॉन रिपीटिंग आर इर्रेशनल नंबर. नॉन टर्मिनेटिंग नॉन रिपीटिंग, नॉन टर्मिनेटिंग नॉन रिपीटिंग आर इर्रेशनल, टर्मिनेटिंग आर रेशनल, non-terminating but repeating are also rational because it can be written in the form of P upon Q. Now finally, summing all these up, the set of counting numbers 1, 2, 3, 4 and so on, or what we call our cardinal numbers or the numbers used for ordering the objects, is known as natural numbers and it is denoted by capital N. If we take the counting numbers and 0, then this set 0, 1, 2, 3 and so on, this set is known as whole number. Now counting numbers 0 and negative of the counting numbers, that is counting numbers 0 and negatives of counting numbers makes the set of integers which is known as I or Z. Now proceeding to the ratio of two integers. Any number that can be expressed as a ratio of two integers, that can be expressed in the form of P upon Q, where both P and Q are integers and Q is not equal to 0, are known as rational number, like minus 0.3, minus 5.4, any proper fraction or improper fraction, a root of 25 that will be equal to 5, that can be written as 5 upon 1, and any non-terminating but repeating 0.3333 like this, and 9.3 bar, this means 3 is repeating, it is non-terminating but repeating 9.33333. This such kind of numbers are known as rational numbers. Now we talk about irrational number, a real number that cannot be expressed as the ratio of two integers. Non-terminating, non-repeating, non-terminating, non-repeating decimal numbers are the irrational number R minus Q. If we remove Q from R, that is R minus Q is the set of irrational numbers. Now we talk about algebraic irrational numbers. The algebraic irrational number is the root of a non-zero polynomial in one variable with integer coefficients like root 2, root 3, root 5, root 150, cube root of 5, or 0.1010010001, likewise 7.1938752, non-repeating, non-terminating decimal. And then we talk about the transcendental irrational number like pi, that is non-repeating, non-terminating decimal. A transcendental number is the non-algebraic number that is not a root of a non-zero polynomial equation with integer coefficient. So this is what we could have discussed about the real numbers: natural numbers, whole numbers, integers, rational numbers, irrational numbers.